Hey everyone, this is Nico from the Decentraland Foundation, and in this video I want to show you how you can use the Utils library together with SDK 7 and the editor to create fun interactive scenes without getting too deep into complicated stuff. So what I have here is a base template scene. I just created a brand new scene with the editor, and I'm going to go into the inspector and I'm going to just mess around and make some default stuff that we'll work on, and we'll create a fun little scene on this. So I'm going to delete this default magic cube. I'm going to go into the scene entity and just add a couple more parcels. So now the scene is at 2x2, so we have more room to play around with. And I'll go into the builder assets and just add some random sci-fi stuff to my scene. And last but not least, I'm going to add this little droid buddy here, which is one of my personal favorite little items that we have from this pack. And with this, I'm going to save my scene, and we will deal with the stuff with this via code now. So I will also get rid of all of the files we don't need. So the default scene template comes with a bunch of things. I will just select all of these files and delete them and just leave the index file. And of course here there's a bunch of imports that won't get recognized, but that's okay. We'll just get rid of those as well. So all we'll have left is the main function right here, completely empty for now. And the last thing we're going to do is we're going to add the actual utils library. So the way you do it is you go to the Decentraland tab and click the plus sign here. Now, I encourage you to check out the documentation for the Utils library. You can find the link for this in the video description. And here you'll find that every single one of the functions that make up this library is documented with descriptions of every property and little snippets you can copy from with a minimal version of each one of these little functions. You'll also see that there are installation instructions here at the very start. And so let's just follow these. So we have to first click this plus icon here, and here Visual Studio is going to ask us what library to install. In this case, we actually have the library name as a suggestion here. This is the very same library that we want to install. Let's just copy it from here just to avoid having to type it out. So again, plus sign, paste this, and is this a Decentraland library? Sure, yes. And now it's just going to install this. It might take a minute or less. And here you will see that it just added this new library to the list of dependencies in my scene. If I wanted to update it, I can click this up arrow and make sure that I have the latest version, although in this case I already should have it. And now, following these instructions, still the last thing I have to do is copy this line to actually import the library into my scene file. So now if I write utils dot, you will see that there's a whole bunch of different options in the auto suggestions, and these are the different functions or the different groupings for functions and a whole bunch of elements that are exposed as helpers in this library. For example, if I were to go to tweens, you see that I can write dot again, and there's a whole bunch of different functions. And if I select one of these, I can see that there's a bunch of different properties that I need to pass for this function to work. So before I dive into this, let's just make sure that we have something that we can actually play with. So let's open the inspector one last time. And remember that I wanted to play around with this little droid guy here. Let's check what it's named in the inspector here. So it's called ball space droid. So we can fetch it from our code and be able to manipulate it from the code. So we can do this. Get entity by null or name, and we now just pass the name of the entity as a string, which is ball space droid. Just to double check, yes, it's ball space droid. You can close now with the inspector, we don't need it anymore. And now just to make sure that it actually does exist, and whatever happens if we rename it or if it gets deleted or whatever, this code still makes sense. Let's write out a little if statement here, and we'll put all of our code inside here. So the first thing we want to do is we want to have a little rotation. So as a nice shortcut, I can rely on the documentation for the Utils library, and so you see here that there is a little snippet already for a basic rotation, and let's borrow from here. And let's write this in. You'll see that it's using an alternative name for a basic entity, but let's use our droid instead. So if I hover here, you'll see that the start rotation function takes a number of arguments. The first is what entity we want to deal with. In this case, it's the droid that we just fetched. And then we'll have a start rotation and an end rotation. And these are quaternions. These are defined here also in the snippet I just pasted. And let's change these from 0 to 180 here. So that rotates on the y-axis, which is perpendicular to the ground. I think it will make more sense for the robot. And so we have the entity itself, the start and end rotations, and then we have the duration, which is how many seconds. In this case, it's 2. And then there's a couple of other optional arguments. They notice that they have a question mark, meaning that these are optional. We will look at them later, but for now, let's do the bare minimum and look at what this looks like this. So let's save, and let's head over to our preview. And here we have our droid rotating. And we'll rotate just once whenever the scene starts running. And if we do one, let's put these tabs side by side so that we can play around with this better. And let's hide unnecessary stuff so that we don't have any more clutter on the screen. So if I were to just leave one line and save again, let's see that the droid performs a smooth rotation. And you'll see that the next property, the optional one, is the interpolation type. So this refers to how the movement is gonna occur over time. By default, it just happens as a smooth linear curve. So the movement of the robot is always gonna be at the same speed from start to finish. But we can actually have a little bit more fun with this and instead use one of the other options. You see that there's a bunch of options, and even though in many cases these are pretty subtle, these are the kinds of subtleties that sometimes unconsciously really get picked up by our brain, and you can see that they actually bring in plenty of personality to a little robot. So for example, if we use the ease expo, you'll see that the rotation has some more of a swag to it. It starts slow, then it goes fast, and then gets slow again. Instead, we were to go with, for example, the ease in elastic. We'll see that it starts linear, or it actually starts with a little jiggle, and then it goes right into a more linear movement. Or we could go with the ease. There's an ease out elastic, where instead it starts smooth and it ends with a little jiggle. And that actually gives our robot quite a bit of personality, right? It feels kind of quirky, kind of disoriented even. So I mentioned that there were two optional arguments. One of them is what we just saw, the interpolation type. The final one is onFinish. And what onFinish does is it lets us run a whole other function when this finished its transition. So in this case, after 2 seconds of running a rotation, we're now able to run some other I have different keywords with different key mappings, and it drives me crazy. Sorry about that. Here we go. So now we have a function that gets called once the rotation finished. And what we want to do in this function is we want to have a movement. We want to have a second tween where we make our robot move to a different position. So let's also borrow from the documentation here, and we'll add this code here. So we will define start and end position. Let's rather put that here, simply to have things a bit neater. We'll have to import the vector3. There we go. And let's copy this line here. which performs the actual tween. And notice that we're doing it inside the function that we're calling after we finished the rotation. And again, this references a box that doesn't exist in our scene. Instead, we are using a droid as our entity. So the translation tween actually looks a lot like the rotation. You have the entity that you want to interact with. There's a start position and an end position and the duration. And then there are two optional arguments, which are the same ones. The interpolation type, which lets you also mess around with the curve of how the movement occurs and how smoothly it starts and ends. And there's an unfinished callback, which also lets you run another function once that is done. And in this case, let's make sure that these numbers make sense. Rather than defining a random vector position, let's instead fetch the droid's current position. So we can do the get. We have to import transform as well, so little light bulb and position. So right now we're fetching the position from the droid's transform component, and once it finishes rotating, it's gonna move somewhere else. Oddly enough, it's not moving to where we actually wanted it to go, but we can mess around with that better. We could actually change our default rotations to something that makes a little more sense. So we can do something similar for the start rotation. Rather than starting out at 0, we can fetch the transform get droid and get its current rotation, whatever it is at that time. And for the ending rotation, let's do something more fun. Let's move the positions. Let's first define the positions and then define the rotations. And you'll see why I'm doing this in just a second. Rather than having a fixed end rotation, let's make the end rotation be whatever direction is staring at the final position that we want to move in. So there's a nice little helpful function for that. We can do quaternion dot from look at, and what this takes is a starting position and a target. So we want to have the rotation that it would take to look at a given direction from another position. So the two properties that we're looking for are the position and the target, and the other property is optional. We don't need it for this in this case. For the position, we will use the same that we're doing here. We will get the droid's current position, and for the position that we want to look at in that direction, let's just use the end position that we have here. And so with this, our rotation and our movements should actually match. Great. I don't know if that was seen right from the start because it took me a little second to look in the right direction myself. Let's do it again, and there we go. The droid looks in that direction and moves in that very same direction. So far we set the basic parameters of the translation. We selected what entity to work on, start, end, position, and the duration. But as you recall, there are two other properties, and we can mess around with the interpolation type to make the movement follow a different movement curve. So go with utils.interpolation type, and we can select, for example, an ease expo, which would have an exponential function from the very start and for the end. So it starts slow and ends slow and moves fast in between. And that's a pretty confident movement. We want our bot to feel kind of scared of the player. So how about we go instead with an ease out quad. So it starts fast and then moves slower when it feels safer and far away from me. So that kind of transmits some of the robot's personality as well through the movement. And now, rather than moving to a fixed position in the scene, how about we instead go for a random position? So rather than selecting the 15 position in the scene, we can go with math.random and multiply this by 32, which is the size of my scene, because it's a 2 by 2 parcel. Each parcel is 16 by 16, so the full width of the scene is 32. And we can do the same with the Z parameter. So now, rather than, oops, I was missing one of these, yes. So now, rather than moving to a fixed position, it's gonna rotate to wherever that random position is and move to that random position. If I were to save and play this again, let's hit an enter and save again, see that it now refreshes and goes to a different random location and goes right there. So far, all of our code runs only once the scene is loaded. But what if we want to abstract away and run this a number of times? Let's refactor our code a little so that we can do that. So let's create a function, export function, and let's call it move joy to random position. And let's just paste all of the stuff that we've just defined here. So basically everything that we put here, including the defining of the start and end rotations and our series of tweens. Just paste it here. And of course, it doesn't know what droid is because it doesn't exist in this context, but we can pass it as a property of this new function that we defined. So we can define an input called droid and make it an type entity. Now entity is not defined here in the scene, but just we can import it with a light bulb, and there we go. And now inside our little function here, inside main, we can call move droid to random position and pass our droid as an argument. So with this, we should have the exact same setup that we had before, just a little bit refactored. And as you can see, it works just as well as it did before. So now what we can do with this is we can call our move droid to random position as a result of whatever we want. It could be a result of clicking somewhere, or in this case, we want to do this as a result of entering the droid's trigger area. And for this, we can use one of the other very cool things that are exposed by the Utils library. So let's comment this out for a minute, and let's go with utils.triggers add trigger. And this function, again, calls for a number of different properties. The first one is what entity we want to deal with. Again, it's the droid. Next, we have two properties that would relate to layers, layer mask and triggered by mask. So in this case, we want to keep things simple, and we will just assign layer 1 to both of them. But note that you can do some things that are pretty interesting and advanced thanks to layers. The whole idea is that some things can be triggered by the player, but also you can have things triggering each other. If you have overlapping trigger areas with each other, depending on what layer they're assigned to and what layer they're assigned to be triggered by, you can have strange and interesting interrelations between the things in your scene. For example, we could have another trigger area assigned to a steaming volcano in our scene, and if our droid were to trigger with that steaming volcano, maybe it gets destroyed or whatever. But it's interesting to know that that is a feature, but in this case we will just keep layer 1 on both. And by the way, the player is assigned to layer 1 by default. So by assigning something to be triggered by layer 1, it will be reacting to the player's presence. Maybe you don't want that, but in this case we do. Next thing in the list is the actual areas. So the shape and size of the trigger areas that we want to react to. So this field is an array. So this is why we need to do the square brackets. And inside these square brackets, let's define an object. And if we do Control spacebar, Visual Studio Code suggests what things we can put in this little object. So in this case, we can define a type. Notice here that we are being told that type can either be the string box or the string sphere. So in this case, let's, for simplicity, make it a box. And these are all the fields we need to pass, because there are default values for the other fields. But in this case, the position is going to be matching the position of the entity, which is what we want. But the scale is going to be a scale of 1 meter, which is, I think, a bit too small for what we want here. So let's explicitly define a larger cube, let's say 4 by 4 by 4, just to represent that the bot is afraid of the player and runs away when we are getting near it. So the next field in our add trigger function is the onEnter callback, which is essentially what we want to do. Like, this is the function that we want to call whenever the player walks inside our trigger area. So let's close the function, the add trigger, and inside this function is where we can call our function that we defined here, the move droid to random position. So let's call it inside here and reference the droid entity. So let's do a quick recap of what we have. So we're fetching a droid entity based on the name that the entity has on the inspector. And then we are adding a trigger function from the Utils library that references this entity, that works on the first layer, that has a box shape of size 4, and that runs a function every time this trigger is called, which references this move droid to random position function. And in this function, every time this gets triggered, we are fetching the droid's current position, we're defining a random position, we are fetching the droid's current rotation, and we are defining a final rotation based on looking in the direction of this random position that we defined before. And then we are using two functions from the Utils library, the rotation tween, which makes the bot look in the new rotation, and then when that finishes, we're doing a movement tween to move to that new position. So let's cross fingers and hope everything works as we expected. Now, the bot does not start with its random movement because we are not telling it to do its random movement at the very start. We're just giving it a trigger, and it will move when we trigger it. So we walk near it, it zooms away. Great, to a random position. If we move near it again, the same would happen once again. Just went through something, of course. Now, there's one there it had a very close position to its last position, so it barely moved. Now, there's one thing that we can improve about this, which is if I were to intercept the bot halfway through, it can sometimes glitch into weird behavior simply because we interrupted its movements with brand new instructions before it finished. Sometimes that works decently enough, sometimes it works a little bit glitchly. And we can avoid this by just having a little flag that basically tells the bot to only start moving, or only pick a new position if it isn't moving already. So we can define a little flag like this. Let droid is this is a boolean, and let's say that it's false at the very start of the scene. And whenever we trigger the bot, let's make sure that that droid is not moving. So yeah, if it happens to be moving when we're triggered, we're just gonna return and not do anything else, so we won't get to call this. But now, if it happens to not be moving, once we have run this, let's say that it is true. So when the scene starts, it won't be moving, but when we trigger it for the first time, it will work as before, but it will set but droid is moving to true as well. So if we trigger it a second time, then this will be true, and it won't be calling this function again. So the last thing we need to do is set it back to false when we finished running everything else. And how can we do this? We can again use the callback function of our last tween movement. So the start translation, remember, had a number of properties, and the last one was an unfinished callback function, just like we had for the rotation. In this case, we don't set anything, but we can, just as we did for the rotation, add a new callback right here. And we can, in this callback, simply set the droid is moving function back to false. So you'll notice that we now have a number of nested functions here, and up to this level, this is reasonably digestible, but it can get a bit nasty and messy with all of these parentheses being closed and open. And this is what's commonly referred to by developers as callback hell. And if you chain enough of these actions, it can get a bit hard to read. So the Utils library actually includes a more advanced way of setting these transitions, and this is with something that we call here an action sequence. Now this is a slightly more advanced syntax that we won't get to into this video, but if you are looking to do something that involves a number of these steps, you might find that your code ends up growing in a neater way if you do things through this different syntax. But for a simple case like this is perfectly acceptable and we can deal with it like this. So now that we are using this flag, hopefully when I run into my bot, I will be able to trigger it the first time without any issue. Here we go. Second time without any issue, but if I try to mess around with it halfway through, you'll notice that it doesn't respond to me until it finished its transition. There we go. Perfect. And if we want, we can do one last little addition, which is when the droid, if we're pretending that the droid is scared of the player, let's make it so that when it finished its last movement, it also rotates to stare at the player. So we can do a tween's start rotation, and again, the properties for these are the droid, and start and end rotation, and the duration. So for the start rotation, we should use the droid's current rotation. So let's do transform get droid dot rotation, and for the ending rotation, we want to look at the player. So for simplicity, let's define these things outside the functions so that we don't get too much clutter. But we still want to define these things within this last function after we did the translation, right? So let's go with const trying to think of a good name for this. Droid last rotation, and last rotation start, last rotation end. And for the end, we're going to do something pretty similar than what we did before, where we want the rotation that it would take for the bot to look at the player from its current position. So we can use the quaternion dot from look at, and we can set the start rotation being at the bot's current position, which should be this end position that we defined before, and the direction we're going to look at is the player's position, and we can get that by transform.get, and we can fetch the player's entity, and this is engine.player entity and dot position, because we don't want the full transform but rather just the position. And so in this tween, we want to use this value as the start rotation, this other value as the end rotation, and we want to assign it a duration. Let's make it a fairly long rotation so it feels like it's slightly scared, and let's also have a tween type interpolation type, and let's go with let's start slow and then go faster. So let's go with ease in expo. So now my bot, when I walk near the little android, it will rotate to another direction, go in that direction, and when it finishes going there, it will slowly look towards me because it's scared of me. And there we have it. Great. So I hope you found this fun and useful, and that you can take these ideas into your own projects. And yeah, make sure to check out the Utils library's documentation and Decentraland's documentation, and can't wait to see what you build with this. Thanks and happy coding.